Now let us look at decimal representation of rational numbers. So in this we'll be looking at two types of decimal representation. One are what are known as terminating decimals and the other repeating or recurring decimals. Finally, let us see how we can convert these decimal numbers to fractions. We are seeing types of decimal representations. First, let us talk about terminating decimals. So, terminating decimals are decimals that stop after a certain number of digits. These are finite and they do not repeat. So, you need to remember that A, they are finite, and B, they do not repeat. What are some examples? Say I have 0.6 or say 0.125, 0.75. Now these are all decimals which are stopping after a certain number of digits. So this has only one decimal place. This has three digits after the decimal point. 0.75 has two digits after the decimal point. So these are always finite and they do not repeat, and these are called terminating decimals. The second kind are called repeating or also called recurring decimals. So as the name suggests, these decimals have one digit or one block of digits that repeat endlessly. What are some examples? Say we have 0.222, so on. So here 2 gets repeated infinitely. Similarly, say we have 0.676767 and so on. So in this, the block which is getting repeated is 67. So 67 is a block which is getting repeated infinitely. In 0.222 it is 2 which is getting repeated infinite number of times. Now let us see how we can convert these recurring decimals to fractions. So for this we follow 4 steps. First, we represent this decimal number, this recurring decimal number, as x. Second, we multiply this x by some power of 10 to move the repeating part after the decimal point. So you will understand this better when we take up an example. Third step is to subtract the original equation from this new equation to eliminate the repeating part. And fourthly, to solve for x and to simplify it to its lowest terms. So let us see an example so that you will understand it. Say I have a recurring decimal 0.444 and so on, and I need to convert this to a fraction. Okay, so this I can also write it as 0.4 bar. So when I say bar on top, this means this is the digit or the block of digit which is getting repeated endlessly. So 0.4 bar. So first step is to call this x. So x is 0.4 bar. Now I need to multiply both the sides by 10 in this case, because if I multiply it by 10, 10x would be 4.4 bar, because this is nothing but 4.444 and so on, and x is 0.4 bar. So why did I multiply it with 10? Because if I multiply it with 10, I'm able to move the repeating part after the decimal point. Okay, so whatever block is there here, I should be able to move it after the decimal point. Now I need to subtract one from the other. So when I subtract, 10x minus x is 9x, and 4.4 bar minus 0.4 bar would be 4. So this would mean that x in this case is 4 upon 9. Let us understand this with another example. Say now I have to convert 1.525252 and so on to a fraction. So first thing is to identify the repeating block. So in this case the repeating block is 52. So this is nothing but 1.52 bar. Now I need to multiply this x with some power of 10 so that the repeating block is moved to the left side of the decimal point. So if I multiply it with 100, I'll get it as 1.152.52 bar, and x is 1.52 bar. Now all I need to do is subtract one from the other, these two equations. So 100x minus x would be 99x, which would be 151. So that implies my x is 151 upon 99. So this we can simplify if required, or convert to a mixed fraction if required. Let's see another example. Say x this time is 2.317317 and so on. So this is nothing but 2.317 bar. Now I can see that this is a block of 3 digits which is repeating. So now I need to multiply it with 1000 so that this becomes 2317.317 bar, and because x is 2.317 bar, I can now subtract one from the other to obtain 999x is 2315. So x would be 2315 upon 999. Let's see another example. Say I need to represent 3.456, 456 and so on as a fraction. So first step is to consider this as my x, and now I will identify what is a repeating block. So in this case I can see that this 456 block is repeating. So, and this block has 3 digits, so I'll just multiply it with 1000 so that I'll get all these 3 digits towards the left hand side of the decimal point. So 1000x would be 3456.456456 and so on. So I'll write it as 456 bar, and x is 3.456 bar. Now I'll subtract one from the other and I'll end up getting 999x, because 1000x minus x would be 999x, would be 3453, because this 456 block will be eliminated when we do the subtraction. So this implies that my x is nothing but 3453 upon 999, which I can simplify further by taking 3 common from numerator and denominator. So this will become 1151 upon 333.